Hi, I'm Canchen. I'm one of the CAs for this course, and in today's special topics lecture, I will be talking about how to build terminal user interfaces using Rust. I guess some motivations on why I chose to talk about this topic is because I really like terminal applications. They're really cool and aesthetic, and I use Linux, by the way, and it's pretty cool, and it's all very pretty. And these applications in particular are written using Rust. And Rust is generally pretty good at writing terminal applications because you want it to be fast, and Rust is blazing fast, right? So yeah. So some of our goals for today is I'm just gonna walk through building a sample uh, application with this library I found called Ratatouille, and in particular I chose this library because it looked pretty approachable, easy to use. Yeah. So I guess to begin with, building a terminal app. Building a terminal user interface without any libraries is harder than one would initially imagine. Because I guess one thing we can talk about is different terminal emulators tend to have different like capabilities. So I listed a few like how does your program deal with like when the terminal size changes or like what fonts are available, like colors. Some terminals can render images, etc. And then another concern is how do we like actually print text to the terminal? I mean, you can just like print text to the terminal, right? But I know on some terminals it causes a lot of like flickering, and then on other terminals it's just like printing a lot of text is not particularly good for when you go back and read the log, right? So maybe there's better ways to handle like updating the text on the terminal, and then how do we handle user input and eh, mouse input too? Is that a possibility? Again, it depends on the terminal, right? So that's why we are using this library, Ratatouille, and it provides an interface for specific like styles and layouts that you can use to display text in the terminal. And basically, the way this works is it kind of like creates like a generic terminal where like it's able to split the terminal into different areas, and then it's able to render text into those areas. So it's able to like create an abstraction for each of the terminals, and then that's where this first part comes in, this cross term as the backend. So Ratatouille provides like an interface that abstracts away all the implementation details about how it's actually rendered to the terminal. And the cross term handles like all these different complexities that we talked about. So that's kind of like the two parts we use Ratatouille to quickly be able to prototype front ends. And then cross term will handle like how do we actually render to the terminal. And then we could talk about some advantages, disadvantages of using a terminal user interface. And I guess the clear one is that it's very lightweight, compared to like having a whole GUI, and there's tends to be less dependencies. And then an interesting choice that Ratatouille uses is immediate mode rendering, where the whole UI gets redrawn every frame. This probably sounds really slow and inefficient, but you can get away with it because it's a terminal user interface. So you're just like literally printing text. And then the advantage of doing this is that there is no state stored in the UI. So we talked about how it has like a bunch of widgets. These widgets themselves hold no state. And the advantage is if I wanted to like quickly prototype and remove, delete components from the UI, this doesn't affect the functionality of my program because all the logic for handling that is somewhere else, right? And we'll kind of get into this point more a bit later. But now we can talk about some of the disadvantages. One of this is that Ratatouille only really handles the front end. You still need more different libraries to handle like the back end and also user input. And then in the end, you're still working with like a terminal user interface. There's a lot of limitations, and maybe a GUI is better for building whatever it is you're trying to do. So I'll kind of talk about the general project structure of building an app with Ratatouille, and then there will be a demo project a bit later. So just bear with me here. But generally, we want to split our project into three parts, where we have like an app struct. This will store like the state of the program, so that's like the data about our program. And then because remember, the actual like UI holds no data. So render takes whatever's in our app and then displays that to the terminal. So these function completely independently. And then finally, we have a run function, which is like the main loop of the program. And this will like handle user input and change the state. So kind of we'll have an app that stores data, render will display that data to the screen, and then run will change that data based on user input. And here, I'm gonna walk through a demo project, and actually we're gonna cut to me walking through a demo project, and I'll see you guys a bit later. Okay, so I'm going to walk through how you could potentially build and structure your own uh, app using this library. And the way I've done that is I've prepared, let's see, four different versions of the same code because watching me type code probably isn't very fun. So I'll just kind of walk through each of them, explain what the general idea is and how they build upon the previous version. But I guess first we can look at what libraries we're using. As I mentioned in the slides, TUI kind of provides the front end that we're using. Crossterm provides a backend for each, and then I have this third library, color which it helps like deal with printing out errors and stack traces, which is pretty useful because in our program we have a lot of stuff that returns results, and I don't want to handle it. So color lets me just kind of like bubble up the result to the top of the chain and not deal with it. This will make sense when I show you, I guess, the first iteration. Let's move this to the main file. Oh, it's already there. Okay, so the general structure of the program is at the start of our code, we'll create a new terminal, and then we're going to run and do stuff with the terminal, and then at the end, we'll restore the terminal back to its original state. So that's what this main function is doing. And then this just says, okay, we're going to initialize our color, and then whatever result we get, we can just return it. So if there's any errors that pop up, it'll get returned back in the main function. So uh, I guess we see what is this run function doing, and basically it takes our terminal. It's going to have this infinite loop, and that's like every frame. What's going to happen is we're going to draw to the terminal, and we're going to handle input. So because if like this is just an infinite loop, we need some way to break out. So I guess the way I set it up is that if we get any key press event, so this event is from crossterm, which is like our backend, right? So that's going to help us handle events like user input. So if we get any key press, we will just break and exit out of the program. And every frame will also draw to the terminal. And what are we doing when we draw? We just have this render function. So again, this frame kind of holds data about the size of the terminal, the position of your cursor, et cetera, et cetera. And the frame comes with this render widget function. And what this does is it takes two parameters, like a widget to render. In this case, our widget is just some text, and then the area to render it to. So frame.area just gets like the whole like area of the terminal. So essentially what this code does is the main function, every frame, we're just gonna draw this text to the whole area of the terminal. And we can just run this project and see what happens. And voila, it draws the text to the terminal, and we can resize it, and while the text is still there, and if we press any key, it'll break out. So that's kind of the simplest iteration with this kind of format. Next, we'll look at the next iteration I have. Let's see. Rust Analyzer is kind of messy when it comes to just copy pasting random code. So wait, let's see. Okay, hopefully this works. But what we've changed is in our render function, we now have this layout feature. And basically, layout lets us divide up the frame into smaller areas. So how this works is Ratatouille provides this enum struct, and it has a couple of different things we can do to it. So first we can specify a direction. So right now it's saying we're going to divide up the whole frame vertically according to these constraints. So this first one says, okay, the first section needs to have a minimum of 5 rows. And the next section is going to take up 75% of the space, and the final section is going to take up the last 25%. And then we're going to apply this layout to the whole area of the frame. And then when we render our widgets, we can just render it to these new areas that the layout splits out. And we can see, yeah. So when we now run this code, let's see what happens. Aha, you can see we've split it up that whole area vertically according to our constraints. The first box has at least 5 rows. The next box takes up 75% of the space, and the final box takes up the last 25%. And the magical part is if we see we resize the terminal, all of a sudden, hold up. Oh, wait, let's try. These boxes get resized too, and our text gets dynamically rendered based on the size of the terminal. So that's pretty cool, right? And then what we can also do is if we want the director to be like horizontal, for example, that also works. And it's now horizontally spinning in the area. So you can see this layout is very flexible, and we can even nest layouts inside of each other divide up our main frame into many smaller subsections. All right, let's move on to the next iteration I have prepared. Let's see. Oops. So what's different about this one is instead of just rendering text, we're now going to render with some paragraphs. These are like some default widgets that are provided by Ratatouille. You can write your own. All these widgets need is like a render function. So uh, again, you can like, I know we talked about traits in one of our previous lectures, and that's pretty much how this works is that all if you want a custom widget, all it needs to do is implement like the widget trait and it needs a render function. But for our purposes for this demo, we're just going to use this default paragraph widget that Ratatouille provides. So I guess the way this code works is we're going to create a new paragraph. It's going to take this text and we can apply additional styling on top. So maybe we want the foreground to be black and the background to be red. So that'll add some colors. And then the paragraph, oh, you could also add a block with borders around it. And it's very, oh, look at that. And why not do both? So again, if we try to run this, let's see what happens. Ta-da! We come up with exactly, I guess what you would expect. So you can apply some styling onto your text and stuff with the default widgets that Ratatouille provides. But, but you'll notice that the common theme throughout these first three is that, well, we don't have much of an app. There's no like functionality, interactiveness really, right? That's again because of the immediate mode rendering that Ratatouille uses. It's that all of these widgets hold no state, right? If we want any state, we're going to have to handle it ourselves somehow. So that's what this final iteration of the app is going to do. Let's pull that up. Oops. Let's see. So this one is still pretty similar to the previous ones, but you'll notice we have this new struct. This app struct is going to hold basically all the state for our application, in which case we just have one number, that's the state. Uh, so how this changes is our app is going to have a new run function and a constructor too, so that we can initialize that at the start of our code. So the constructor, well, yeah, you can see what it does. It just basically constructs it. And then we moved our old run function into the app. So it's again still an infinite loop. It's still going to draw to the terminal every frame, except now we're going to upgrade the event handling code. So whenever it gets a key press, it's going to check. If it's right, we're going to do some stuff with our state. If it's the left arrow, we're going to do some other stuff with our state. And then if it's anything else, we're just going to break out. So, and then we upped our render function as well. It's very similar to the previous one, except now instead of the text being static every time, we could use our state to change what we're rendering, right? So if we just, let's see, if we run this, what happens? Ta-da! And it comes with, wow, we can push some buttons to change the state. So that's the general, like, I guess this final iteration would show how you could build your own, like most apps are structured with Ratatouille. It's that we need to have a separate struct or somewhere to put all our state. And then we still have the main run function, which will handle the loop of we're going to render to the terminal every single frame. And then we're also going to handle events like user input. And depending on what that input is, we can change our state accordingly. And then the render function is just going to use the layouts and paragraph and widgets and different styling and whatever to render to the terminal. So that's the general layout for how you could build a project with Ratatouille. Cool. So hopefully past me did a good job walking through the demo project. But as a recap, kind of the things I covered was again the project structure and then how to use different layouts and styles and how to handle user input. And in particular, I'd invite you guys to think about the project structure because um I know some of these other things are probably not very applicable for other projects that like aren't this, but um I think a lot of you probably come from like CS 124 and 128 where there's like a lot of object-oriented programming. And kind of this project structure kind of flips it on its head because it's like instead of having different classes that store data, it's like we isolate all the data in one place. We isolate all the logic for rendering in one place, and we isolate all the logic for handling user input in one place. So it's a different way to divide up your project structure. So maybe it's worth thinking about. And yeah, and then maybe here's some other cool projects that use this specific library for inspiration. So Yazu is a cool file manager in your terminal, which is very interesting. And then Oatmeal is a basically a wrapper for ChatGPT, but it runs in your terminal, which is very cool. And then here's a terminal interface for Git. Although you might as well use Git on the command line, but if you hate